Hi, my name's Dave Roberts. I'm a design lecturer in IT Sligo in Ireland, and I've worked with a team of scientists and engineers both inside and outside the college centred around County Clare, who have developed a ventilator that can be made from very, very low cost components and very relatively low technology. So this unit is made of plywood and can be made by an electrician and a carpenter. There's virtually no electronics in it at all. It utilises a standard wiper motor, a power supply which comes from a PC, and a motor controller, which at the moment we're using a unit that we can buy off the shelf from Radionics, but a motor controller can be made with a transistor and a couple of resistors and a potentiometer, very, very simply. Going to turn it on. We're using an ambu bag, which we have very, very carefully calibrated to get exact and precise volumes for the patient. That's the test lung. Test lung is filling. I'm just going to turn it around to you. And you can see this is set for 600 at the moment, milliliters of tidal volume, and I'm able to adjust it with this hand wheel up to 700 or down to 300. And it's a very, 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 very simple adjustment. And this unit just has a little threaded nut up here, and that can go up and down. There's a trapped nut there in a slot, and that allows the unit to go up and down. Next feature of it is the IE ratio, and we've selected an IE ratio of 1.7 here for 700 volume. So you can select an IE ratio of 1.7, 2 or 3 or even 1 for whichever volume you're deciding to apply to the patient. The last element in the ventilator is setting the breaths per minute, and obviously this wiper motor, as it rotates with the crank, one rotation is one breath. So 12 breaths per minute is just 12 rotations per minute, and simply. And if you don't have a controller with some sort of a data readout, you just count it with a stopwatch, and you can set it actually pretty precisely. Looking around the back of the unit, and that's our controller. We've got a battery backup on this. That's our PC power supply, and everything else is just straightforwardly out of an electrical shop. In its most simple iteration, this machine just needs a battery charger, a wiper motor and a controller, and obviously the adjustable shelf and the scale, and you're in business. So it doesn't have to be as complicated or as well finished as this, which has machine guards, etc., etc. It can be a very, very simple unit, but this is very simple. All this is just plywood, a bit of acrylic to protect it, and a wiper motor, which sometimes you can get them new, but if you can't get them new, you can get them out of a scrap car or out of your own car, or you can get a PC controller anywhere. Thank you. Okay, so here's the components of our ventilator. Nothing too complicated. We've got a power supply here taken out of a PSU, and we'll have a short video showing how to take the tappings off that power supply for your voltage for running the wiper and your voltage for charging a battery if you need to charge a battery. Wiper motor itself, this is a Bosch unit. It came out of a Ford Focus as it came from the scrapyard. And these motors come in different wattages. This one's 55 watt, they go down to 40 watt. They come in left hand and right hand versions. This is they all come with the same arrangement of 3 screws and the central thingy. That's the bracket, and a motor bracket obviously has the 3 screws for the fitting. This arm that goes onto it, normally the arm is 43mm centres. but not always. So you might need to have to make up your own arm. And if you do that, the hole that fits onto the motor has a little tapered splined connector here. So if you need to make up your own bracket, right, you need to drill an 8mm hole and open it up with an 18-degree included angle by creating a modified drill tip to create the taper on the inside of that for clamping down onto that connector. This is a 6300 bearing. If you can't get a 6300 bearing, you can make one up in nylon or timber, and the important thing is 35mm outside diameter, and that gives you a relationship of 60mm from the outside of the bearing to the center of the motor here. There are some critical dimensions in making the unit. Obviously the pivot from the actuator arm to the center of the motor, and these heights relative to the base are important. So the horizontal dimension and the vertical dimension are important, as is the relationship between the actuator and the shelf. So that relationship between the actuator and the back of the shelf is important for where the bag is centered, and that's important for calibrating the bag, as is this piece of plastic here, which is just a rainwater downpipe. It's got an internal diameter of 64mm, which fits across the arm, and an outside diameter of I think 67mm. This is important because this has been calibrated with the bag, so don't use a different diameter, and you can actually make this, you can turn that down with a piece of wood if you need to make the same diameter. The bearing inside this is a 10mm nut and a small copper fitting, which is a 1/2 inch Hydrodair connector, which is Hydrodair is a sort of plastic pipe. It's very, very simple. This is the mechanism for the volume adjustment. I used a riv nut. You can put in a nut there and spot weld it on. Really, really very, very simple. But again, this has to be made as accurately as possible. All these dimensions are on the website. Last item is the controller. And controller unit, we're using a unit from Radionics here. It's 4179728. It's an off-the-shelf controller. Again, on the website there's a circuit. You can make up the circuit yourself. You don't need anything as complicated as this. And really, that's our unit. This is a ventilator of last resort. It's a control ventilator, which means it's used for comatose patients who are fully anaesthetized. It's not a support ventilator. So we can certainly make it very cheaply. It can calibrate volumes accurately and can deliver, I suppose, support to the patient accurately. We've had it running here for some weeks. We have used the ambu bag with it. Some other bags we tried weren't as flexible as the ambu bag. All those bags are designed to be used for a short trip in an ambulance going to hospital. But certainly we've used this bag for some weeks without any problem or difficulties at all. It's a ventilator of last resort. If you do need a ventilator, you can make one up with the help of an electrician and a carpenter, and you can make them up in a very, very short time. You can make them more or less complicated depending on how far you want to go or how far you need to go. Good luck with it. Thank you.